Hello, scholars. This is Mr. Lowe. I hope all is well with you. In this video, we're going to go through section 4.6, which focuses on complex numbers. So first part of this lesson was taught previously, so we're going to do a brief recap on the basic concepts of imaginary and complex numbers, and then get into the operations of complex numbers, namely adding, subtracting, multiplying, and dividing. So remember, the basic thing about a complex number comes from the idea that before Algebra 2 trig, you were probably told that you couldn't take the square root of a negative number. In higher level math, we can actually do that using the imaginary unit, I. So I is equal to the square root of -1. That's what allows us to take the square root of a negative number. So for example, if you have the square root of -9, how you would solve it is you would take the square root of 9 the way you normally would. So the square root of 9 is 3. But since the number was negative, you would put an I in the answer. So that allows you now to take the square root of a negative number. It's just going to have I in the answer. Same rule apply if you had to simplify the square root. So for example, if you have the square root of -12. So 12 is not a perfect square, but we can simplify it into 4 times 3. The square root of 4 is 2. The square root of 3 would remain under the square root. So that gives you 2 square root of 3, but you would put the I behind it because the number originally was negative. So the I is the imaginary unit. It simply allows you to take the square root of a negative number. What derives from that is concept number 2. I squared is equal to -1. So anytime you see I squared, you automatically substitute it for -1. So for example, 5I squared would be equal to 5 times -1. I squared comes out, -1 goes in its place, so you get -5. So that takes care of that. Another example, 7 minus 3I squared. So same rules apply. So that gives you 7 minus 3 times -1. A negative times a negative is positive, so 7 plus 3 equals 10. 7 plus 3 equals 10. So first 2 parts are your basics of the imaginary number. Now, when you take an imaginary number and a real number and combine them, that's what gives you a complex number. So a complex number is in the form A plus BI. That is the standard form of a complex number. So the A represents the real part, and BI represents the imaginary part. So A plus BI. So for example, if you had 3 plus 6I, that means A would equal 3. That's the real part. And B is equal to 6. That's your imaginary part. So there's always a real and an imaginary part to the problem. And last but not least, if 2 complex numbers are equal to each other, then real has to equal real, imaginary has to equal imaginary. So this scenario comes into play when you have to set up an equation of some sort. So let's actually do that. Let's say you had 4A plus 5 plus 6I equal to 17 minus 8I. So here's your equation. again, real has to equal real, imaginary has to equal imaginary. So instead of 8i, I'm going to make that minus 8bi. So we're going to be looking for A, and B. So we match real to real, imaginary to imaginary. So on the left-hand side, 4a plus 5 is the real component. 6i is the imaginary component. On the right-hand side of the equation, 17 would be the real component, and negative 8bi is the imaginary component. So if two complex numbers are equal to each other, then real equals real, imaginary equals imaginary. So we would set up our equations as 4a plus 5 equals 17, and 6i equals negative 8bi. So now that everything is set up, we solve two equations. First equation is pretty simple. Subtract 5 on both sides. So 4a equals 12. Divide by 4, a equals 3. On the right-hand side, now since both sides have an I on it, you can cancel the I's out. So the I's drop out. So you're left with 6 equals negative 8b. That becomes a basic one-step equation. So you get negative 3 over 4 equals b. So if you're given one of those higher order problems, that's how you would go about solving it. Nothing too much to stress over. So these are the basic concepts associated with imaginary and complex numbers. Now we'll go one step further and actually do computation with complex numbers, namely adding, subtracting, multiplying, and dividing. Plus side here is essentially if you know how to combine like terms, do distributive property, then you're in good shape when it comes to working with complex numbers. So let's switch it over to adding and subtracting. Let's start with adding and subtracting. So adding and subtracting, we add and subtract the same way we normally would. Combine our like terms, do what we need to do. However, the real number always goes first. The imaginary part always goes last. You always want your answer in standard form, a plus bi. You always want your final answer in standard form. Now, when you are adding and subtracting, it is very, very easy to confuse the problem as a multiplication problem because you see parentheses all over the place. Always look for the signs sitting in the middle. Look for a sign sitting in between your complex numbers. That's going to tell you what you're doing. The signs are going to tell you what you're doing. Now, if there is no sign, that's multiplication. So for example 1, 2 plus 3i plus 4 minus 7i. So you're adding. So combine your like terms. 2 plus 4. 3i plus negative 7i. 2 plus 4 gives you 6. 3i minus 7i plus negative 7i is minus 4i. That's that. Problem's over. Example 2 with subtraction. So negative 7 minus negative 3. Negative 3i minus positive 4i. So negative 7 minus negative 3 is negative 4. Negative 3 minus 4, negative 7. There it is, and there it goes. So adding and subtracting, you're still just combining like terms. So with example 3, you have 3i plus 17 minus 5i minus 4. Again, combine your like terms. So 3i plus negative 5i and then you've got 17 minus 4. So that leaves you with negative 2i plus 13. Now remember, it has to be in standard form. Has to be in standard form. Real comes first, imaginary goes last. So your actual answer is 13 minus 2i. 13 minus 2i. If you leave it out of standard form, it technically is wrong. If you leave it out of standard form, it's wrong. So one more with adding and subtracting. So when you have 3 complex numbers, that's fine. You just got to follow the progression, work from left to right. So negative 16 minus 5 plus 11. So negative 16 minus 5 plus 11. So negative 21 plus 11, negative 10. Do the same thing with the i's. 8i minus 3i plus negative 5i. 8i minus 3i plus negative 5i. 8i minus 3i, 5i. And then 5 plus negative 5 is 0. So that's 0i. So your answer is negative 10 plus 0i. But since I was 0, you can also just write this as negative 10. So either one of these is acceptable. Either one of those is fine. Either one is fine. So adding and subtracting, still pretty simple. Combining like terms, putting it back in the standard form. Very simple to work with. Next up is multiplying. Next up is multiplying. Now remember with multiplying, that's distributive property, that's FOIL. If you were taught Punnett squares, you can use Punnett squares. However, remember the rule. If you see I squared pop up in that problem, you must replace it with negative 1. The second you see I squared, you must replace it with negative 1. So example 1, 6i times 3 plus 2i. So this is a multiplication problem because there's nothing separating the two complex numbers. There's no plus sign or minus sign in the middle. So we distribute. 6i times 3. So 6i times 3, not jump the gun here, gives you 18i. And then 6i times positive 2i, that's 12i squared. I squared popped up. So I squared comes out. So that's 12 times negative 1. So that gives you 18i minus 12. Remember, we need it in standard form. Negative 12 plus 18i. Negative 12 plus 18i. Again, you must put it in standard form. That's a non-negotiable. All right, so example 2. So example 2, we've got 3 plus 2i, 4 plus 3i. So 3 times 4, which gives you 12. 3 times 3i, and I'm going to list each part here. 3 times 4, which will give you 12. 3 times 3i, positive 9i. 2i times 4, plus 8i. And then positive 2i times positive 3i, 6i squared. So now we got some combinations that we can do. So you got 12, 9, and 8 gives you 17. Remember, I squared, take the I squared out and put in -1. So that gives you 12 plus 17i minus 6, which is equal to 6 plus 17i. Remember, the imaginary unit always goes last. If that problem looks familiar, it was one of the extra credit questions on your last test. All right, so let's work another one, example 3. 5 minus I times 3 minus 4i. Same rule applies. So 5 times 3, 15. 5 times -4i, -20i. I times 3, -3i. Negative I times -4i is positive 4i squared. Positive 4i squared. So we combine where we can combine. So 15, -20 minus 3 is -23i. And then I squared is still -1. So 15 minus 23i minus 4. 15 minus 4 gives you 11 minus 23i. 11 minus 23i. So it's not a hard problem. Will work, but not a hard problem. Not a hard problem at all. So let's finish off multiplication with example 4. So 5 times 5, 25. 5 times -2i, -10i. 2i times 5, positive 10i. 2i times -2i, -4i squared. -4i squared. So bring down to 25. -10 plus 10, well, that's 0. Well, that's a 0. So those drop out. -4 times -1. So a negative times a negative is positive, and 25 times 4 is 29. So sometimes when you multiply, the i's will drop out. So that doesn't mean you did anything wrong. It just meant that the i's dropped out. It'd be like that sometimes. And actually, example 4 is something that you're going to see quite frequently when we do dividing complex numbers, when we divide complex numbers, which is what we're about to do now. So before we can divide complex numbers, then we have to know something called the conjugate. So if you have a complex number, then the opposite of it is known as the complex conjugate. The opposite is the complex conjugate. So if you start with a plus bi, the complex conjugate is simply a minus bi. Simply change the sign attached to the imaginary part of the number. So the sign that's in the middle, take the opposite of it. So 5 plus 3i, if you were given 5 plus 3i, the conjugate would be 5 minus 3i. Just change the sign attached to the imaginary part. Negative 1 minus 2i becomes negative 1 plus 2i. So those are opposites. So, second rule with complex conjugates. If you multiply two complex conjugates, you will get back a whole number. Although sometimes sometimes it can be an integer, can be positive or negative. Get back a whole number. It can be positive or negative. Could be positive, it could be negative. So example 3, you have 5 plus 2i and 5 minus 2i. So you have a complex number and you have its conjugate. So you have a given complex number and you have its conjugate. Remember, the conjugate is its opposite. Conjugate is its opposite. So if this problem looks familiar, we solved it in example 4. We solved it in example 4. So this answer was 25 minus 10i plus 10i minus 4i squared. The middles dropped out, and we changed I squared to negative 1. 25 plus 4 is 29. So we got a whole number back. It just so happened to be positive this time. It could be negative. It could be negative, so don't think it can't happen. Don't think that it can't happen. All right, so we're going to wrap this thing on up by doing division of complex numbers. We're going to divide complex numbers. So dividing complex numbers is a process. Dividing complex numbers is a process. So the steps are up above, so we're going to follow it step by step. So step 1, find the complex conjugate of the denominator, of just the denominator. So for example 4, the denominator is 2 plus I, so that means its conjugate is 2 minus I. Just change the sign that's in the middle. Step 2, multiply the numerator and the denominator by the complex conjugate. So you're going to multiply the top and the bottom by the complex conjugate. So that gives you 3 times 2 minus I and 2 plus I times 2 minus I. Now you got to multiply it out. Don't just leave it like that. We multiply it out. So if we multiply the top, you get 3 times 2, 6. 3 times I, negative 3i. For the bottom, 2 times 2 is 4. 2 times negative I, negative 2i. I times 2 gives you 2i. I times negative I is negative I squared. Remember, I squared comes out, negative 1 goes in its place. So 4 minus negative 1, which gives you 5. So when you divide complex numbers, your bottom your bottom part of the fraction should always be a number. So if your bottom is not a number, you did something wrong. If the bottom is not a number, you did something wrong. Good hint to keep on. So now we divide our two answers out. So now we divide everything out. So that's 6 divided by 5 minus 3 divided by 5i. And those can't be reduced, so that's your final answer. Those can't be reduced, so that's your final answer. Again, not a hard problem, but it is a problem that you need to keep an eye on. So there's our first example. Let's do a second example. So example 5, we have 6 over 2 plus 3i. So we're going to make it a little bit more difficult. We're going to make this 6i. So we're going to make the top 6i over 2 plus 3i. So 6i over 2 plus 3i. Level up a little bit. So how we solve it doesn't change. Take our denominator, find the conjugate. The conjugate is 2 minus 3i. So that part doesn't change. That part doesn't change. Multiply the numerator and the denominator by the conjugate. Multiply both by the conjugate. So then we do that work. So 6i times 2 is 12i. 6i times negative 3i, negative 18i squared. So I squared pops back into the problem. So we replace it with negative 1. So that gives you 12i. So negative 18 times negative 1 gives you 18. So 18 plus 12i is at the top of the fraction. Eighteen plus 12i is at the top of the fraction. So now we work the bottom of the fraction. So the bottom of the fraction, 2 times 2 is 4. 2 times negative 3i, negative 6i. 3i times 2, positive 6i. 3 times negative 3, negative 9i squared. So 4, the middles are going to drop out again. Negative 9i squared becomes negative 1. Negative 9 times negative 1 is 9, which gives you 13. So once again, if you do it correctly, the bottom should drop out. You should have a whole number back. Positive or negative, doesn't matter. You're going to have a whole number. So the last thing is just to divide. 18 divided by 13 is 18 over 13. No decimals here. No decimals. Leave it as a fraction. Plus 12 over 13i. So the division part doesn't really come until the end of the problem, but you still have to do the division part. Still do the division part. So it does. So you get a lot of practice with multiplying and dividing in this type of problem. So let's do one more. Last example here. 5 plus 2i divided by 3 minus 2i. Same rules apply. Denominator, the conjugate of the denominator, 3 plus 2i. So you multiply the numerator and denominator by the complex conjugate. Multiply the numerator and the denominator by the complex conjugate. So if you do the numerator, 5 times 3 is 15. 5 times 2i, 10i. 2i times 3, 6i. 2i times 2i, 4i squared. So combine everything up, 15 plus 16i. I squared is equal to -1. So 4 times -1 is -4. 11 plus 16i. 11 plus 16i. Denominator, we do the exact same way. 3 times 3 is 9. 3 times 3 is 9. 3 times 2i, 6i. -2i times 3, -6i. 2i times -2i, -4i squared. So then you do your simplifying. So 9, 6 minus 6 is 0. I squared is -1. 9 plus 4 gives you 13. So 11 plus 16i over 13. So 11 over 13 plus 16 over 13i. Now, just because it didn't take place in here doesn't mean that you wouldn't have to reduce sometimes if you needed to reduce. So if 16 over 13 was 16 over 12, then yes, you need to reduce the fraction. Just because it didn't happen in any of our examples doesn't mean that it can't happen. So don't get lost in that fact. But other than that, that completes section 4.6. The first part of this lesson was going through the basics. The second part was doing adding, subtracting, multiplying, and dividing. Remember, adding and subtracting, if you know how to combine like terms, you're good. Multiplying is distributive property in FOIL. Dividing, get the complex conjugate, multiply the top and the bottom by it, and then simplify. It's not hard, it's just a little work. So I'm highly confident that you can do the work. That being said, if you have questions, please feel free to ask. Otherwise, take care. And of course, have a good one.